Hello, class. Um, Before we start learning the actual syllabus of pre-calculus math 1240, I would like to give a quick review of the fundamentals or the basics that you would learn throughout the course. To begin with, let me start by defining a set. A collection of well-defined objects is known as a set. So you need to pay attention to the word well-defined. And a set can be denoted by a capital English alphabet with elements listed inside flower braces. So, what are elements? Elements are nothing but objects inside a set. For example, you have S to be equal to 1, 2, 3, 4, 5, where S is a capital English letter, and you have elements that are numbers up from 1 to 5 listed within the flower braces. There are certain notations involved with sets. So you can observe here the element 1 is inside the set S. Therefore, 1 belongs to S, which is represented by this symbol. And 6 does not belong to S, which is represented by this symbol. So there are two types of listing or writing sets. So one is you list all the elements inside a set. For example, if I would like to list all the elements from 1 to 6 or all the elements which are greater than 0 and less than 7. So I list all the elements. So for example, A, which is equal to 1, 2, 3, 4, 5, 6. So this is one way of writing a set. The another way is you write the rule based on which you would like to represent the set, or you would want to list the set. For example, set builder method, which is A, which is equal to all the elements X, where X is of the form where X follows this rule. That is, X is greater than 0 and less than 7. So this is called a set builder method. Now we shall learn something about number systems. The first number system, I would like to explain things based on sets. So you represent set of all natural numbers by n. So natural numbers include elements from 1, 2, 3, 4, 5 up to infinity. You can observe that 0 is not inside this set because 0 is not natural, and even negative numbers are not inside this set. Then we have Z or Z, which is the represented by which represents set of all integers. So set of all integers, and why the letter Z? Because we adopted mathematicians thought to adopt the German language for integers, that is Zahlen. So integers have all the negative numbers, 0, as well as all the positive numbers. The next number system is Q, which Q represents quotient. So Q is nothing but the set of all rational numbers, which has elements of the form P by Q, where P and Q belong to Z. That is, P and Q are integers, and Q can never take the value 0. Q can never be equal to 0. Here are some examples. -1/4. So -1 and 4 belong to integers, and 4 is not equal to 0. Therefore, this is a rational number. Then 0.176, which can be written as 176 divided by 1000. This follows the rule mentioned here. So that is 176 and 1000 both are integers. Again, 1000 is not equal to 0. The third example, -10, which can be written as -10 divided by 1, and 0, which can be written as 0 by 1, and 10 by 1. So all the three numbers, sorry, all the three numbers are integers, and they follow the rule mentioned above. Therefore, they are in Q. Next is Q complement, so which is represented by Q and overhead C. Q complement in the sense which are not rational numbers. So they are called as set of all irrational numbers. So how do we define irrational numbers? They are the numbers which are not rational and which cannot be represented as fractions of integers. For example, we have square root of 2. So every fraction can be written as a decimal. Therefore, when you are writing rationals here, you could write 0.176 as 176,500, but you cannot do the same with root 2. Like if you consider 2 by 3, so this can be written as 0.66 and 6 and 6 and so on. This 6 repeats infinitely many times. So that cannot be done with root 2 over here. And the decimal tail will have non-recurring numbers infinitely many, and this is a never-ending process. So therefore, this cannot be written as a proper fraction as we can do it here. Therefore, they are irrational numbers. Then we move on to real numbers. Real numbers that is represented by R are rationals as well as irrationals. So therefore, you have natural numbers, integers, rational numbers, as well as irrational numbers in R. So set of this R represents set of all real numbers. These real numbers can be plotted on a line called real line. So you can see the line here, which starts from minus infinity. You have all the negative numbers here, and you have a rational number that is negative 1 over 3, and 0, 1 over 2, as well as root 2, and all positive numbers going up to infinity. So between two integers, you have infinitely many rational numbers and irrational numbers embedded in them. We shall now quickly go through the properties of real numbers. The first property is the commutative property under addition and multiplication. So commutative property implies where this symbol here represents for all elements of the form AB in real set of all real numbers. It doesn't matter how you operate, uh, how it doesn't matter how you add the numbers or how you multiply them. The order doesn't matter. So A plus B is equal to B plus A, and A times B is equal to B times A. For example, 3 plus 7 is 10, and that is 10 is also equal to 7 plus 3. So the order of adding the numbers doesn't matter. And 3 times 7 is 21, and 7 times 3 is also 21. So this is satisfying commutative property under addition and multiplication. Real numbers also satisfy associative property under addition and multiplication. So the grouping doesn't matter. For all A, comma B, comma C belonging to R, if you add A and B first and then add C, it is same as adding B plus C first and then adding A to it. So the same thing applies to multiplication. If you multiply A and B first and then multiply C, or B and C first and then multiply A, it is one and the same. So for example, if you consider uh, for multiplication 3 times 7 times 5. So you will multiply 3 times 7 first, that is 21, times 5, that is also equal to 105. And sorry, 105. And if you multiply 7 and 5 first, that will be 35. So 3 times 35 is also same as 105. So you can also do the same for addition. So 3 plus 7 is, if you add them first and then add 5, that would be 10 plus 5, that is 15. And if you add 7 plus 5 first and then multiply, add 3 to it, it would be 3 plus um, 12, that is 15. Then we shall go to the next property, that is distributive property. Multiplication is distributive over addition. So for all A, B, C belonging to real numbers, set of all real numbers, you can distribute the multiplication operation for over addition. Like A of B plus C is same as AB plus AC, and B or B plus C of A is same as BA plus CA. You can give an example for this. So 2 times 3 plus 5 is 2 times 15. That will be, sorry, uh, it's not 15. Yeah, 2 times 8, so that is 16. And the same thing can be done in this way, that is the RHS. So where 2 times 3 plus 2 times 5 is 6 plus 10, so that is also equal to 16. So you can observe here, if you apply the commutative property for each term, you will get it to be equal to AB plus uh, AC. So which is same as this, the first equation that we wrote and verified with an example. Next, we shall go to the operations in set theory. Let us define the operation union. If A and B are two sets, then A union B is the set of all elements in A or in B. For example, if I define A to be set with elements 1, 2, 3, 4, and 5, and B to be a set with 3, 4, 5, 6, and 7. So A union B will be a set with 1, 2, 3, 4, 5, 6, and 7. There may be common elements, as in this example, there are common elements that are 3, 4, and 5. Yeah, so you need not write them twice. You need to list all the elements which are in A as well as in B, or in B once. So that is A union B, which is again a set. The next operation is intersection. If A and B are two sets, then A intersection B is a set of all elements in A and B. So for the same example written above, so A intersection B, as I said, the common elements in both the sets are 3, 4, and 5. So you write all the elements which are in A as well as in B and list them as one set. So that would be the intersection of two sets. We have more notations where this is a null set. Null set is an empty set which is denoted by 5, the Greek letter. And for example, an example of null set, if you define A to be set of all x such that x is an odd number, and B to be set of all y such that y is an even number. So if you take intersection of these two sets, A intersection B would be a null set. Oh, I'm sorry. You're not supposed to write that. A is a null set. So the mistake that I did here, writing the phi inside flower braces means that you are listing the Greek letter. It doesn't mean the set is empty. Either you have to write empty parenthesis or phi. Then we have a subset. So subset is if A is contained inside B properly. That means there are some elements which are not in A, but there are elements in B. So then this is a proper containment. If we are not sure whether A is equal to B, this can be A can be a subset or A can be equal to B. So this is an improper containment. So this we say that this we call that A, we call A as a subset of B, and A can be subset or equal to B. So this is an improper subset. So subset of real numbers are intervals basically. So we denote intervals in this way as listed here. So the first thing is an open interval a comma b. You can plot them on the real line like this. This is an interval which has all the elements between a and b but not including a and b. So you graph them to denote that a and b do not include inside the set are not inside the set. You have a hollow circle or an unshaded circle at a and b, but you have this shaded part of the numbers or of the line between a and b. So the same thing applies to semi open or semi closed interval here. These two, this is open at a and closed at b. So this is a set which includes b and all the numbers between a and b but not a. So that has been represented here. The same thing applies here. The difference between these two is it is open in an inverted way. It is open at B and open closed at A. So this includes A and does not include B, but includes all the other numbers in between A and B. So to explain, I will explain the infinite interval uh, now. So this is an infinite interval. So where this includes a and includes all the numbers up to infinity. So this goes on up to infinity. So this is like it includes all the numbers from minus infinity to b. So this is the set builder notation that represents all these intervals. So these are all subsets of R, that is set of all real numbers. So the same thing has been explained in this slide where A takes the value of 1 and B takes the value of 2. You can go through them. Now I shall explain what is an absolute value. So to define an absolute value, if A belongs to set of all real numbers, then the absolute value of A is nothing but A if A is greater than or equal to 0 and negative A if A is less than 0. For example, if you consider absolute value of 7, it is 7 because 7 is greater than 0. And absolute value of 0 will be 0 itself. And if you have negative 7, it is negative of negative 7, that would be always 7 and which is always greater than 0. So you can, what does this absolute value of a real number gives us? So it gives the distance from the point A on the real line to 0. There are certain properties of this absolute value. So as you saw above in this example, absolute value of a real number is always greater than or equal to 0. And absolute value of a negative number and the positive number are the same number. Negative A and positive A is one and the same as you observed it in this example. Absolute value of 7 and absolute value of negative 7 are one and the same. And if you multiply absolute value, if you take the absolute value after multiplying two numbers, or individually apply the absolute, take the absolute values of each number and multiply them, they are equal. So we can verify this by considering minus 2 times 5. So if you take the multiply them first, so it would be minus 10. So take the absolute value, it is 10. So, but then if you individually take the absolute values, it would be minus absolute value of 2 times absolute value of 5 would be 2 times 5, it is 10 again. So the same thing applies to division. You divide two real numbers and then take the absolute value, or take the absolute value of the numerator separately and denominator separately and divide them. They are equal. And this is called as triangle inequality, where absolute value of a plus b is less than or equal to absolute value of a plus absolute value of b. We can check this as well. So consider minus 2 again, and plus 5. So this would be absolute value of 3. So as 3 is greater than 0, it is 3 itself. And if you take the absolute value of each of the terms here, so absolute value of minus 2 plus absolute value of 5, as explained here, it is 2 plus 5, that is 7. So 7 is greater than 3. So it is satisfying this inequality. Then we shall define distance between 2 points on a real line. So if a and b are real numbers, then the distance between them is denoted by d of a comma b, which is nothing but absolute value of a minus b. So for example, we can take if we want to find out the distance between minus 5 and 2, following the definition, it would be absolute value of minus 5 minus 2, so which is equal to minus 7. So this is absolute value, as this is negative 7 and it is less than 0, it would be negative of negative 7. So that is 7 itself. You can observe that absolute value of a number, of a real number, can be denoted as distance between 2 points. It is distance between a and 0, which is a minus 0, which is nothing but absolute value of a. So we can also check one more property of distance between two numbers. Uh, Distance of a comma b is equal to, by definition, it is absolute value of a minus b. We shall check whether this is equal to distance of b comma a. So distance of b comma a, if we apply the definition, is b minus a, which is equal to, um, if you take minus 1 common, so this will be equal to a minus b. So this can be treated as two real numbers, so x and y. So this would be xy. If we apply the property of multiplication here, so that would be absolute value of x times absolute value of y. That is nothing but absolute value of minus 1 times absolute value of a minus b. As this is less than 0, so the absolute value would be 1 times, this is absolute value of a minus b, by definition, is a comma b. So d of b comma a is equal to d of a comma b. So with this basics, we can learn further and get into deep learning of pre-calculus. Thank you.